Now we will investigate the scenario where ice is accelerating down on a icy surface. So icy surface means that frictionless, there is no friction, the surface is smooth. So we will first of all, we know that this is theta, this is 90. So first of all, this we know that this is mg. We will resolve this vector mg into two components. This angle is theta, this is mg cos of theta, and this is mg sine of theta. So if we parallel shift this mg sine of theta, parallel shift basically means we change the position of the vector in the plane, but we don't change its magnitude and directions. So this mg sine of theta is like this. Now the only reason in this case the body is sliding down is one of the reasons that the object slides down on an incline is due to the parallel component of its weight. So this is mg sine of theta. Imagine now there is no friction, so the resultant force, and there is in this case we assume that there is no external force. We just put ice on this icy surface, there is no there is no external force, so the only force which is causing the body, the ice, to accelerate is the parallel component mg sine theta. So we know that resultant force equals to mass into acceleration. The resultant force, first of all we have to understand what is the resultant force. If the body, if it's a cart which is which has a mass of 10 kilogram, it is accelerating forward 500 newton, backward 300 newton, so the resultant force is 200 newton. Forward force is plus 500 newton, backward is minus 300 newton because the vectors are the opposite direction. F equals to ma. F resultant, this is the net resultant force, 200 newton divided by mass is 10 kilogram, so 20 meter per second square will be the acceleration. So in this case there is no friction, the only forward force is mg sine of theta. There is no friction, neither there is any forward force, the only forward force is mg sine theta equals to ma. So if we want to find the acceleration, we make a the subject, mg sine of theta divided by m will give you acceleration, so g sine of theta will give you acceleration. This is the formula for finding the acceleration on a icy surface. Now through this formula I also want to understand one thing, is that if the angle between the plane, the inclined, the plane and horizontal surface is 0, so what happens? For example, if this is like this, if the body is like this, the weight is acting downward, so g is basically the gravitational acceleration in this case. So in this case, if the angle is 0, the only the perpendicular component mg cos theta is actually equal to mg. How? If the body is on a horizontal plane, the weight the perpendicular component of the weight is actually equal to the weight itself. This is because we know that the perpendicular component equals to cos of theta. G cos of 0. What is G cos of 0? G cos of 0, cos of 0 is 1. So G cos of 0 is 1. So this actually tells that on a plane surface, the perpendicular component is actually the weight itself. If we use G sine of 0, this will give you 0. So this means on a horizontal surface, there is actually no parallel component. So this was what I was going to tell. But if the body is on a plane which is 90-degree, weight is still going to act downward. If we plug G sine theta as the form of acceleration over here, G sine of 0, so G sine 90 is your acceleration. Sine 90 is 1. So when the body is placed on a vertical plane like this, the only component acting is going to be the parallel component, and G is actually 9.8 meter per second square. So when the body is falling vertically, only the parallel component of weight is responsible for accelerating the body down, because G cos of 90 is actually 0. G cos of 90 is 0. So 0 equals to 0. The perpendicular component is not responsible for accelerating the body in this case.